Yo, AP Chem. Today we're going to be talking about an extension of stoichiometry in solution and talking about something called a gravimetric analysis. And in this case, we're going to be specifically talking about a gravimetric analysis by precipitation because we're talking about precipitation reactions. So when we talk about gravimetric analysis is a method in analytical chemistry. And analytical chemistry is exactly what it sounds like. It's chemistry where you specifically analyze quantities of things. It's a whole class that you can take in college. And it is, an analytical method to determine the quantity of an unknown what we call an analyte or an unknown substance based on the mass of a solid that we produce in a lab. And so the type of gravimetric analysis that we're going to be doing is something called precipitation analysis. And what it does is it uses a precipitation reaction from something that's unknown to separate one or more parts of a solution by taking that unknown thing and getting it stuck in a precipitate. And when we get it stuck in the precipitate, we can analyze the amount of the precipitate and then figure out what that unknown is. So here are kind of the steps that you follow in a gravimetric analysis. What you need to do is you need to take your unknown sample. A lot of times it's an unknown solid, and then you take that unknown solid and you dissolve it into a solution that you know the volume of, okay? Then you take the solution and you mix it with something that you suspect the precipitate will get kind of trapped in or get trapped in a precipitate. So one of those ions will get stuck together and then you can figure out what is in there. So you got to use kind of your knowledge and make that precipitate. Then what you do is you take your precipitate and you separate it from the liquid in the mixture, which is called the supernatant. So you take that and usually you run it through a filter and then you remove the supernatant, which includes any excess ions or your spectator ions, and then you just pay attention to the precipitate. Then you take the precipitate and you dry it in a drying oven for an extended period of time. And you weigh the precipitate. And then what you do from there is you calculate the amount of the ion in the sample that you trapped in the precipitate and then do the math with it. It is an involved process and it kind of makes sense once you get explaining it, but I just want to kind of walk you guys through it step by step. On the College Board AP exam, are they going to give you a full problem or they just give you all this data and don't break it down step by step? I'm not sure. I would doubt it. But I want to have you guys know the process so that if they ask you a question about it, you know what they're talking about and how to figure it out. So this is just kind of an image of what the setup is going to look like. Now, you could have just a regular gravity filter happening where the water just comes out because the water is being pulled down by gravity, or you can also get a setup of something called a Buchner funnel and you have a vacuum to it. So you'd hook it up to a vacuum source and then it pulls all of the water out of it. And so if we don't have the vacuum flask, so we do the gravity filter and then we let it sit into a drying oven for a little while. Okay, so here's the example I'm going to walk you through. And what I would recommend doing is as I walk you through it, I would pause the video and write things down because what I'm going to do then is I'm going to give you a sample to work on and work through and check your answers for. Okay, so here is the example that we're going to work through step by step. And I'm not even going to pull my doc cam up. I've got all the math kind of worked out here for you, and we'll walk you through it step by step. So it says that a certain barium halide, and halide is a halogen ion, exists as the hydrated salt BaX2. So what that means is X is our halogen. We don't know what it is. And then there are two of them in this formula. And then it's got two waters attached to it. So it's a dihydrate. A sample of the halide, 0.265 grams, was dissolved in 200 milliliters of water and excess sulfuric acid added. The mixture was then heated and held at boiling for 45 minutes. The precipitate, barium sulfate, was filtered off, washed, and dried. The mass of the precipitate obtained was 0.2533 grams. Determine the identity of X. Now, like I said, I don't think they're going to give you a problem that's probably this open-ended where they're like, boom, you just need to know all the math for it. What they're going to do is they're going to walk you through the steps, and I will do that same thing in our example problem. So I'm going to walk you through the steps here, and then we'll kind of break it down one part by one part. Okay, so the first thing that you need to do is you need to get your balanced equation. And in this case, we know it's a barium halide. Now, you say to yourself, I don't know what that means, but when you think about it, this is realistically a double replacement reaction. Even though there's this H2O component in there, when you put hydrated compounds into solution, those waters just disappear. So what we really have is just a double replacement reaction. So if you think about what's going to happen, barium has a +2 oxidation number. Halogens have a -1. So when we do our little swappity-doo with our cations, the H is going to partner up with the X, and the Ba is going to partner up with the SO4. So our balanced equation is going to be 2HX's. Remember that the little subscript of 2 from the reactant side does not travel over because H has a +1 oxidation number and X has a -1 oxidation number. It's going to make barium sulfate, and it's going to get 2 waters. And the important part about this is we're going to need this reaction for our stoichiometry. And we're going to need it because we're going to have to take our precipitate that we made and figure out how many moles of stuff we started with in the first place. So step 2 is going to be to calculate the moles of the unknown ion that got, or the unknown substance that got trapped into the precipitate. So if we go back here, what's happening is we took some mass of this and trapped the barium ions into a precipitate. Okay, so we don't know how many moles of this stuff we put in there, but we know that all of this stuff here got trapped in the barium precipitate. And every last little bit of barium that came in this precipitate comes from the salt at the beginning. Okay, so what we need to do is we need to figure out how many moles of barium we got trapped in here. And what that's going to do is it's going to tell me how many moles of the original I actually put in there. So if we think about starting off, we collected 0.2533 grams of barium sulfate to begin with. If I convert that to moles, and then I use my mole ratio, it's 1 mole of barium sulfate to 1 mole of our unknown. It tells me that 1.09 times 10 to the -3 moles of this unknown substance here caused this precipitate at the beginning. Okay? So if we do the reverse stoichiometry, this amount of precipitate was caused by this many moles of the barium halide compound. So that's what we got to do first, always with all of these. Okay, the next thing we need to do is if we know how many moles of unknown stuff went in there, and we know the mass of how much those moles weighed, what we can do is we can figure out the molar mass of a compound. Now, up till this point, we have really not talked about molar mass being calculated any other way than using your periodic table. However, if you have data for the number of moles of that substance you have and how many grams that weighs, if you take the grams of the substance, divide them by how many moles you have, you get your molar mass. It's grams per mole. Grams over moles. So in this case, what I did was I took the grams that I had and I divided them by the moles that I just figured out from the previous problem. And what this tells me is it tells me that my unknown compound weighed 243.12 grams per mole, roughly. Okay, so this is starting to give me some clues about what that mystery compound is, because I know that when all of the pieces of it, the barium, the 2 halides, and the 2 waters are in there, I know that all together they're going to weigh 243.12 grams. Okay. Step 4 then is to take away everything from the molar mass that you already know is in that compound. So what I mean by that is this 243.12 grams comes from, like I said, a barium and 2 waters plus the 2 halides. So if we can take out the 2 halides here, if we can take out the barium, ooh, this looks crazy. Hold on here. I gotta get out of here. Hold on. Problems. Cut and paste situation. Yikes. Okay, let's try this again. Sorry about that. Um, if you take this 243 and I subtract the mass of the barium, which is 137.33, and I take away the mass of the two waters in my formula, that leaves me with 69.76 grams of the molar mass coming from that mystery substance. So what I do now is I know that the mystery substance that's in there, that mystery element, two of them weigh about 70 grams or so. What that lets me do then is it lets me know the mass of the unknown element, or it lets me find that and helps me identify it. Now, because in my formula there were two of those halides, I know that each of them weighs about 34.88 grams or 35-ish. Okay, they're the same element, so it means that my two things both each weigh about 35 grams. And if I look on my periodic table at my halogens, then my halogens, the one that weighs about 35 grams is the chlorine. So it's give or take, a half a gram here or there. But in general, it's the closest to chlorine. So what that tells me is that my chemical formula here is going to be barium chloride. So the idea is that I use my stoichiometry to figure out how many moles of chemical are in there, then figure out the molar mass of that unknown chemical, and then figure out what unknown is inside there. Okay? We would have done a lab had we been in person, but I'm just going to have you run through a sample problem, and then we'll kind of talk about some potential issues that you could have when we do the lab. Things that could potentially cause you errors in this situation are not having your precipitate dried all the way. So if we go back and we kind of trace the math here, if I have too high of an amount of precipitate here, it is going to give me a larger number of moles that I started with. And as a consequence of that, if I have the same mass divided by a larger number of moles, what will happen is my molar mass is going to be smaller than I expected it to be. And then the masses that I have will be off a little bit too. But the idea behind gravimetric analysis and a lot of this stuff is that you can figure out the unknown from your chemical reaction by taking the data that you have. So like I said, I'm going to have you guys run through a problem on your own. I'm going to have you walk through it step by step, and then you're going to check your problem, see how well you did, and we'll go from there. Okay? If you find yourself having any questions, please make sure you get them cleared up. Good luck.